Today's lesson is on lines of best fit. By the end of this lesson, you should be able to choose a line of best fit for data being displayed in a scatter plot. You should also be able to write the equation for lines of best fit using given lines or choosing two data points to create a line. All right, so let's start out with some definitions. What is a scatter plot? All right, a scatter plot is just a graph with points plotted to show a correlation or an association between two sets of data. All right, the data is plotted on a graph using the XY coordinates. So for an example, weight versus height. I could plot weight on the x-axis versus height on the y-axis. An association is a relationship between two sets of data. So we use this in mathematics and in science, right, to determine if two different variables are somehow related or associated. And a line of best fit is a straight line that comes as close to all the points on the scatter plot as possible. We use a line of best fit in mathematics to make predictions. Right? We also call this line the trend line. So if we lay out a ruler over the graph and adjust it until it looks like it's closest to all the points, that would approximate a line of best fit. The goal is to try to get maybe about half of the points above that line and half of the points below that line. All right, so like we said here, the goal is to have as many points above the line as there are below the line. All right, so let's talk more about correlation or association. Right, when two sets of data are strongly linked together, we say they have a high correlation or a high association. Right, the word correlation is made up of the words co, which means together, and relation. So nowadays they use the word association, and it means the same thing, right? It's talking about the relationship between two variables. All right, so when we have a positive association, that's when the values increase together. All right, when we have a negative association, that's when one value decreases as the other increases. Right, so below is what a scatter plot of each type of association might look like. So look on the left-hand side here where we have the red scatter plots. These are all called negative associations or negative correlations because they are going downhill from left to right. You can see that as one variable increases, in this case on the x-axis, the y variable decreases. So it's like when you learned about the slope of lines. If you have a negative slope, you have a negative correlation or a negative association. It's different from when we have a positive association, like the blue graphs here on the right. So notice how, in general, they're trending upward from left to right. So think about the slope of a line again. If we have something that's going uphill from left to right, that's a positive slope. And in this case, it means a positive correlation or positive association. The more tightly the lines or the points are packed together, the higher the correlation or the stronger the association. So notice here on the left, all of these points on this scatter plot make a perfect line. So that would be an example of a perfect negative association. Here we have points that are very closely packed together. They don't make a perfect line, but pretty darn close. So we say that they have a strong negative correlation. Right, and that is also true of when we have positive correlation. So the slope of the line itself doesn't matter. It doesn't matter how steep or shallow that line is. It matters how tightly packed those points are to making a perfect line. That's what determines how strong the association is. Take a look at the green graph in the middle. Here we have points scattered all over the grid, right? And that would indicate no correlation. It means we have two variables, right, that are not related in any way. So for an example might be the sale of hot dogs at a baseball game and the average grade of students in my 8B class. Right, those two things should not be related. All right, so now let's take a look at a line of best fit. Take a look at the scatter plot to the right. Does it have a positive association, a negative association, or is there no association? Right, well, in this case, we can see that this scatter plot, these points here are trending downward from left to right. All right, so that's kind of like the negative slope of a line. All right, since they're trending downward from left to right, I can see the pattern. I can see a pattern here. I can make a prediction. If I extended this graph out to 8, and I had to say, where do I think the next point would be? I would probably choose somewhere in here, right? Because that's following the pattern downward from left to right. So it has a negative association. And I would look at this graph and I'd probably say it has a pretty strong negative association. Right? We can draw a trend line now that would approximate this data. So let's go ahead and draw one. So remember, my goal is I'm going to freehand this. Right? If I had a ruler, this would be much better. So my line's not going to look perfect. But my goal is to try to draw a line right through the center of all these points so that it's close to as many as the points as possible, and I have an equal number of points above and below the line. I don't know, so I'm guessing here. I'm going to draw, and to me, maybe it looks something like, and forgive me if my line is not perfectly straight, but something like that. That's a pretty good trend line. So we could use this line to make predictions about, say, if I had a point at 8 here, whatever this represents on the x-axis, it would be about right there. And remember, that was just my eyeball. That was just a guessing technique. In statistics, there is an actual way to calculate a line of best fit. There's a mathematical way to do it, but we're not going to include that as part of the lesson today. If you ever take a course in statistics, then you'll talk more about exactly how to come up with that line of best fit. Okay, so here we've drawn a line of best fit. It looks reasonable to me. And now I can use that to make estimates. So we can talk about what do I think the slope in this case of the line is, or the y-intercept. All right, so if I want to estimate the slope of my line, I'm going to try to find points on the line that I can identify that come as close to these grid marks as possible. And then I'm going to use that to estimate. All right, so again, this isn't an exact science here, but I'm going to pick maybe this point, and let's see if I can come up with another one that's pretty close to a corner. How about this one? All right, so we count. Remember, slope is rise over run. So slope is equal to rise over run. And I'm going to count the rise. So if I'm going down to get from one point to another, that would indicate a negative number for the rise. So in this case, I have to go down maybe 1, 2, 3. All right, so I'm going to say that the rise was -3. Now I want to talk about how far I have to go to the right to get from one point to the other. So that's the run. And we go 1, 2, 3 again. So -3 over 3. So -3 divided by 3 is -1. So in this case, I'd say that a reasonable estimate, remember this is just an estimate for the slope, is -1. Remember, I drew this line myself using my eyeball, trying to get as many points above and below the line as possible. All right, so let's do that again for this one. I want you to take a moment and pause the video and answer the following questions. What type of association does this scatter plot indicate? If you were to draw a line of best fit, where would it be? And what would be a reasonable estimate for, this time, the y-intercept of the line that we drew? All right, so for the question of what type of association this scatter plot represents, you should have said that it is a positive association. It's going uphill from left to right. As one variable increases, in this case weight, height also increases. Now we're going to draw a line of best fit that approximates this data. So again, remember, I'm trying to go in here and I'm trying to cut this right down the middle, like if I was slicing it right down the middle as closely as possible so that half of the points are above and below. All right, so I'm going to draw a line. Again, this is my estimate. My line's not going to be perfect. And we're going to draw. I'm going to continue this out. All right, so that's a reasonable line of best fit. I have about half of the points above and about half of the points below. If anything, the slope looks pretty good. Maybe I could raise it up a little bit. All right, so now let's estimate, the y-intercept. So remember that means here when we cross the y-axis. So here I can see here's 10 on the graph. If you can't see this on your video, that says 10. The next tick mark here says 20. And it's not quite halfway. Halfway would be there. That would be 15. It looks like it's in between 10 and 15 then. So maybe 12 or 13. Okay, so we can say the y-intercept is about equal to, remember this isn't an exact mathematical science here, but it's about equal to 12, maybe 12 and a half or 13, somewhere in there between 12 and 13. Hey, why don't we just split it right down the middle and call it 12.5? So if I were asking you this question, on a checkpoint or a quiz or an exam or some kind of informal assessment, if you gave me any number that was somewhere around there between maybe 11 and 14, I would say it was reasonable. Again, remember there is an exact mathematical way to get that line of best fit and to figure out the y-intercepts. But when I give you no points and I don't give you the data set itself, the only thing you can do is make estimates just looking at it and eyeballing it like we just did. So let's continue that out and let's use it to actually write an equation of a line. And in this case, we're going to choose 2 points. And we're going to use those points to write the equation of a line. All right, so first, we don't ask it here, but you should all recognize this as being a negative association because it's going downhill. It's trending downhill from left to right. So it's a negative association. And the slope of the line that we come up with is going to be a negative slope. Has to be, right? Or else it's not a negative association. All right, so again, we're going to estimate this when we draw this line of best fit. Okay, so I'm trying to cut it down the middle. I'm trying to eyeball it here, maybe somewhere through here. And so that seems pretty reasonable for my line of best fit. I have about half the points above, half the points below. Seems to split it down the middle. Now we're going to write an equation for the line using rough estimates for 2 points on the line. So most of the time in your checkpoints and exams, they'll actually label the points for you. But if we were to do it on our own, is what I would be doing here after I drew my line of best fit is trying to pick 2 points that were as close to that line as possible. And I have a few options. It looks like I have 3 points, 1, 2, 3 here that are almost right on top of the line that I drew. So I need to choose 2 of them. All right, so any 2 that are as close as I want. So I'm going to choose this point here. If I can find my mouse. There we are. All right. So here's a point I'm going to choose, and maybe this point here. Let me get rid of those other lines. All right, could I have chosen this point? Yeah. But I had to pick 2, so I'm picking the ones with the green boxes. And now I'm going to need coordinates for those points. All right, so in this case, I would say I'm going to kind of look at the XY coordinate here. I draw this down and over. So to me, this point, again, I'm doing a slight estimate here. There's 5, this is 4, so it is at the coordinates 4 and 7. And there's 5, 6, 7. So we have a point at 4, 7. All right, now I need some coordinates for my other point. All right, so in this case, I'm going down. This point looks like Maybe it's 6.5. Might as well. Let's go ahead and make it as accurate as I can. So I'm going to call that point 6.5. Put my x coordinate. And again, on the y coordinate, it looks like about 5.5. All right, so I'm going to use these 2 points to write an equation for a line. And if you need a review on how to do this, just go anywhere, even Khan Academy, and search up writing the equation of a line using 2 points. So that's exactly what we're going to do. So remember, we're going to write the equation of the line in slope-intercept form. So that is our y equals mx plus b. We need 2 points. We need 2 numbers, excuse me, to write this equation. We need a number for m, and remember that's our slope. All right, and we need a number for b. That's our y-intercept. Okay, so this time we're going to use these 2 points that we indicated here to find the equation for the slope. The slope equation is m is equal, when we have 2 points, right? The difference between the y-coordinates divided by the difference in the x-coordinates. All right, so it doesn't matter which point we call point 1 or 2, as long as you're consistent. So I'm going to start here. I'm going to subtract my y-coordinates. So those 2 points, make sure you subtract a y with another y, not a y with an x. We'd never do anything with subtracting, an x and a y coordinate. So here we're going to do 7 minus 5.5. That's our rise. We're going to divide that by our run, which is the difference in our x coordinates. So in this case, 4 and 6.5. So I'm going to write 4 minus 6.5. Notice how I stayed consistent. I started with this y coordinate first on the top, so I had to start with this x coordinate first on bottom. All right, now we can use this to actually calculate a value for that slope. Okay, so 7 minus 5.5 is 1.5, so 1.5. And 4 minus 6.5 is negative 2.5. All right, since I'm working with decimals here, I think it's appropriate to get a decimal answer. So I'm going to go ahead and divide those out. And I'm going to say 1.5 divided by 2.5. Now I know my answer should be negative. When I do that, I get 0.6, and it's going to be negative 0.6, right? Because a positive divided by a negative is a negative. All right, so we get negative 0.6 for our slope here. That's one of the values that we need to write the equation. So we have one. We know what the m is now. Now we need a way to figure out the b. And the way that we do that is by plugging in one of our original points in for the x and the y, because remember, these do represent an x and a y that is on the line. So I'm going to choose whichever one I think is easier, and to me, the one without the decimals looks easier, these nice whole numbers over here. So I'm going to plug that in. So for y, I'm going to write 7, right, because 7 is the y. This is our y, right, remember? And this is what I'm going to plug in for the x. All right, so far we know now that 7 is going to be equal to the slope, which we just figured out was negative 0.6, times the x-coordinate, which in this case is 4, plus the y-intercept, which we don't know. We're not quite sure, and that's why we have an equation now that only has that variable left, so we can solve for it. Now looking at the line of best fit I drew, it looks like it might be somewhere around 11. Right, but remember, this line is an estimate. It didn't go exactly through those 2 points, but it should be somewhere around there. And if I get a number around there, then I know that what I have for my b is reasonable. So let's go ahead to my calculator again and multiply negative 0.6 times 4. All right, so I pull that up and I go negative 0.6 times 4. So that value is going to be negative 2.4. So I have that 7 is equal to negative 2.4 plus b. And then to solve for b, I need to add the 2.4 to both sides. All right, so when I do that, I come up with a value that b is equal to 9.4 positive. So remember how I did that? I isolated the b by adding the 2.4 to both sides to get the b by itself. Okay, well now we have all the values we need. We have a value for the slope and we have a value for the y-intercept. So I can go ahead and write the equation, the line y is equal to negative 0.6 x plus 9.4. All right, so in this case, it was lower than what I thought. And that could indicate two things, that my graph that I have here isn't square, or that, remember I drew a line that was a reasonable guess to go through all the points, but then I picked these 2 points. All right, so then perhaps, right, that my slope that I drew of my line is a little too shallow compared to what the equation states. But when we worked it out exactly using our chosen points, then we came up with this equation. So in your checkpoints and exams, they will label the 2 points they want you to use. Because if they didn't, everybody would come up with a slightly different answer. All right, so they'll go ahead and label which 2 points they want you to use, and then you'll go through this process, right, to find the equation of the line. And we'll practice this again, but in summary, right, you first have to find the slope using the 2 points. Then you plug in that slope along with one of the given points into the equation y equals mx plus b and solve for b. Then the last step, of course, is to write the equation of the line, substituting in the values you found for the slope and the y-intercept. So here's a good example. I want you to pause the video and see if you can write the equation for the line of best fit that goes through the 2 labeled points that I indicated here. All right, so you should have been trying to write the equation in slope-intercept form, y equals mx plus b. So when I do these, I like to always write down the form first. Kind of reminds me what my goals are and what I'm trying to go after. In this case, I know that I need a number for b and m. So those are my goal. I'm trying to solve for those. And step 1, always when you're doing this, is get the slope. So we're going to get the slope first before we can find the y-intercept. All right, so when we have 2 points, the slope is equal to, we say y2 minus y sub 1 divided by x2 minus x sub 1. Now when I'm saying x2 or x sub 1, that's just the way in math that we differentiate between the 2 different y-coordinates, right? Because here's a y-coordinate here and here's a y-coordinate here. So when I put the little subscript 2, that's just for me to way to say the y-coordinate of point 2 minus the y-coordinate of point 1. And again, it doesn't matter which one you call point 1 or 2 as long as you're consistent. All right, so I'm going to go ahead and I'm going to calculate the slope. And here I'm going to go again. I'm going to subtract my y-coordinates. Okay, so in this case, I have 20 minus 15. I'm going to divide that by the difference of the x-coordinates. So in this case, the 2 and the 6. So I write 2 minus 6. All right, so when we calculate out that slope, we're going to get 5 over negative 4. Now you could go ahead and write that as a decimal if you wanted to, as negative 1.25, or you could just leave it as this fraction. So in this case, I'm just going to leave it as the fraction. All right, now we're going to use this slope along with one of our points, right, to solve for b. So we've done step 1. We figured out what m was. Now we need a value for the y-intercept, the b. Remember how we get that is substituting into this equation the values for the slope and one of our points. It doesn't matter which point, right, as long as you use the x and the y from a single point and don't go in between points. All right, so usually I pick the one that looks easier. They both look reasonable, about the same. I'm just going to pick this top one, this 2 and 20. So make sure, though, when you're doing this, that you're not plugging in 2 right here for the y because it's the first number in that ordered pair. Remember, that value is the x value. The 20 is the y value. So it's the 20 that I have to plug in for the y. All right, so here I have 20 is equal to our slope, -5/4, times our x coordinate, which is 2 in this case, plus b. All right, now we're going to go about solving this equation for b. So in this case, that I get that 20 is equal to -10/4. Remember, if you need to take a whole number, put it over 1 like this, so you multiply across when doing fractions, you can do that, plus b. And then now I'm going to go ahead here and, in this case, solve for b by adding 10/4 to both sides. All right, so b would be equal to 20 plus 10/4. Remember why it's a plus here and not a minus, right? Because I had to add it to the other side to get it across the equal sign. All right, so if I take 10 divided by 4, that's the same as 5 divided by 2. That's 2.5 as a decimal. So if I do 20 plus 2.5, I'm going to get 22.5. You could have also left that as a fraction, or if you had wanted to. All right, so now finally I can write the equation of my line of best fit, which is equal to y equals the slope. Oh, there it is, -5/4 x plus 22.5. So if you're doing this and you're looking at a multiple choice quiz and you don't see 22.5 here, maybe it's because they wrote it as a fraction. Right? So if I really wanted to convert 22.5 to a fraction, remember I could write that as 22.5. And then I could change that mixed number into a fraction if I wanted to by multiplying these two. So that would be 44 plus 1, 45/2. So this 22.5, maybe it's left like this as a decimal. Maybe they write it as a reduced fraction, in this case 45/2. All right, so the last type of problem we're going to look at is estimating a line of best fit. So here's a scatter plot. And the question is simply, which line appears to be the line of best fit? Which one do I believe would be the line of best fit given this data, the scatter plot? So remember, your goal is to find a line that looks like it goes through the middle of all the points and is as close to all the points as possible. So this red line here does not look like it approximates all the points. Because in general, the trend that I see is horizontal. I don't see this set of data trending upward or trending downward. So I'm going to exclude the red line and the green line here from being possibilities. So now it's between one of these three horizontal lines here, the purple, the black, or the orange. And again, in this case, you're using your eyeball and deciding which one of these splits it down the middle. All right, and in this one, you can see that it was in this case, the black line appears to cut it down the middle. So that would be a reasonable choice for the line of best fit. If you are watching this asynchronously, make sure you go back to my course announcements and answer the questions.